Hello everyone, in this lecture we will be going over 2008 USAMO problem number 2. Here's a view of this problem and a simple sketch related to this problem. So we are given an acute triangle ABC. It turns out to be scaling triangle, and let M, N and P be the midpoints, and you can clearly see them on this sketch as well of the respective sides. Obviously, let the perpendicular bisectors of AB and AC, namely PD and NE here, the red lines which show clearly the perpendicular signs, they intersect the ray AM or line segment AM in points D and E respectively. So these 2 points appear. And let lines BD and CE intersect in point F. Later on you connect these points E and D to C and B respectively, and you realize an intersection between these lines. Let's call it F, and that point, it turns out to be inside the triangle ABC. We would like to show that these 4 points actually lie on a circle. Well, in order to prove this result, notice that 3 points would define a circle, obviously, and our points are, at least 3 of our points, namely A, P, N, have a very special position. Here you can see these 90-degree angles here. So what I claim is that because those 2 perpendicular bisectors intersect at point O, which is the circumcenter of our triangle, the claim is simple. So this circle, there exists a circle which goes through points A, P, O, and N, such that AO is the diameter. So let me go ahead and draw this diameter, that proposed diameter here. So we have this line, and so the proposal is that, let me just clarify this line a little bit here. So because of these 90-degree angles, those angles would subtend the diameter, and obviously the diameter would be AO. So all we need to show is that now that we know there exists a circle which goes through A, P, O, and N, all I need to show is that point F lies on that circle. So basically, let me show that. We already know that 90 degrees is equal to angle APO, which is equal to angle ANO. And we would like to show, that's a question mark up here, that angle AFO is also 90 degrees. Once this is proven, it implies F. Obviously, if AFO is 90 degrees, that angle would subtend the diameter, and as a result it would be on the circumcircle of triangle, well, on the circle which goes through these points A, P, O, and N. So far I know that observe A, P, O, N are concyclic points. Concyclic. Okay, so all I need to show, as I said again, F is in such a position such that AFO is actually 90 degrees. Let's first observe that triangle ADB is isosceles. Obviously, ADB is isosceles. Why would that be? Because BP is equal to PA, because P is the midpoint, and we have a perpendicular bisector. As a result, ADB, so triangle ADB is isosceles, and as a result AD would be simply equal to DB, and AD is equal to DB. In a similar way, triangle AEC is also isosceles, and as a result AE is equal to EC as well. So I will call the angle ABD as X, and because we already mentioned this isosceles triangle, this angle up here all the way obviously is also x degrees, and let me mark it with a different color. I'll just call this angle here as y, y, and obviously because of isosceles triangle, this is also y. And angle BAC, therefore, notice that angle BAC is equal to angle x plus y. Notice also that angle BOC, angle BOC, so let me make a sketch here. So this line and then this line. So I propose that this angle up here, this angle BOC, oops, sorry for that. So this angle up here, angle BOC, is equal to 2 times x plus y. For a good reason, consider the circumcircle of triangle ABC. Minor arc BC is subtended by the central angle BOC, I should say, and it's also subtended, that minor arc is also subtended by angle BAC, where A is on the circle, so therefore angle BOC would be 2 times angle BAC, which is x plus y. That's why we have 2 times x plus y. So let's move on to the next page, and in the next page I will apply some trigonometric facts. Particularly I will apply the law of sines, and there we are. So let me rewrite those equivalent angles one more time. I think in the previous page I have the x in green color and the y in, so this is the x here, that's the x here, and now I already have in red color that one, the y here, and the y down here. So I applying the law of sines, so therefore apply law of sines. So we obviously on triangles, well, AMB and AMC, AMB and triangle AMC. We just realized that BM over sine x, BM over sine x is equal to AB over sine, AB over sine AMB, or BMA, AMB. And in a similar way, I can apply law of sines on that other triangle ACM. So from here we would get that CM, I think I have enough space, so CM over sine sine y is equal to AC over sine CMA. Now what I will do is I will take these the ratio of these two, or the quotient, if you will, of these two equations, and also noticing that sine angle AMB is equal to sine angle CMA because they are supplementary angles up here. So therefore the signs would be the same. So we just find out that, so this would imply, after I take their ratio, so let me actually do it on the following line. So I have BM over CM times sine y over sine x is actually equal to AB, oops, that's a B here, over AC times sine angle CMA over sine angle BMA. And that whole thing is simply because angle CMA and BMA, as I said earlier, they are supplementary angles, so therefore I would get AB over AC. But because BM is equal to MC, it turns out here this is just a single one, so therefore what we have, therefore we got that sine y over sine x is simply equal to AB over AC. And then what I will do, I will again apply a pair of law of sines on a pair of triangles ABF and triangle ACF. So let me go ahead and draw that additional line that I need up here. So starting from point A, I will go through F. So let me open a new page actually, and on that new page we can go on with those results, I assume. So let me redraw this line one more time. So the line going through F, as I said earlier, and let me remind you of the angles again one more time. So we had in the previous page, I believe we colored the X as green, and as a result, so I have this one is X, this one is also X, because we have an isosceles triangle ADB here. In a similar way, using the red colors, I know this whole angle is Y, and this whole angle is Y again by isosceles triangle AEC. So what I have in mind, as I said in the previous page, I will apply law of sines on triangle, on these pair of triangles AFB, AFB, and on triangle AFC. So as a result, applying law of sines here, so I would have AF over sine X, obviously, is equal to AB over AB is this length here, so therefore it is opposite of angle AFB, sine angle AFB. From the other one we get that, so let me rewrite immediately. So AF, so again this distance is opposite of this angle up here, sine Y is equal to, and then AC over opposite AC would be angle AFC, so sine angle AFC. So again, we take the ratio of these two equations. So after some simplifications, what we will get would be, so this implies sine X over sine Y is equal to AC times sine of angle AFB divided by AB times sine of angle AFC. And by the result that we got in the previous page, let me remind you of that result, particularly this one, that sine X over sine Y is AC over AB. So if I replace sine X over sine Y with AC over AB from the previous page, let me mark it with a different color, so AC over AB. Now looking at the first, this one and this one, we realize AC and ABs are cancelling those ratios, so therefore this would imply that sine angle AFB is equal to sine angle AFC, and this kind of suggests that those two angles are actually equal, but we need to make a small adjustment. I need to prove that both of them are either greater than 90 or less than 90, so this way I can confidently say that those two angles are definitely equivalent. So I'm looking into these two angles up here, so this one, and let's call it like that, I guess. Okay, so those two angles. So make the following observation actually, so that we can easily prove that observation. Notice that angle ADF is an exterior angle to triangle ADB, obviously, right? So this is an exterior angle up here, and we have EDF, angle EDF, therefore is 2x, right? Because those two angles were x, so therefore that angle up here is 2x. And similarly DEF, so this angle right here is simply 2y, because we have two interior angles that add up to 2y. So I have 2x and 2y here. and therefore angle EFD is simply equal to, let me write that down, angle EFD obviously would be 180 minus, and consider triangle EFD, so 180 minus 2x minus 2y, and that would be simply equal to 180 degrees minus 2 times x plus y. Again, remember from the previous slide that, actually 2 previous slides, that 2 times x plus y is simply angle BOC, or you can say 2 times BAC. So let's go back to our slide. So we have 2 times angle BAC, or so 2 times angle BAC, but that immediately implies that that sum, okay, so that's what we got, but at the same time, notice that angle BFC, I should say, angle BFC, so therefore this angle up here, so this angle BFC is 2 times BAC. Why would that be? Because these two interior angles, they add up to this one, which is 2x plus 2y, 2x plus y. So therefore we can say angle BFC is equal to 2 times angle BAC, which is just x plus y. But then 2 times BAC is simply BOC, as I showed in my very first page. 2 times. So that's angle BOC. But then, so we just proved that BFC is equal to BOC. So therefore, let's draw these additional lines here and up here. So what we did is we did show that this angle also is 2x plus y. So as a result, this implies that actually points B, O, F, and C are concyclic because those two angles, BOC and BFC, they subtend the same arc BC and they have equal angles. So as a result, that those 4 points are actually concyclic. So let me move to the next page and conclude the proof. So I just carried 2 previous results from, so we just established that B, O, F, and C are concyclic points because angle BOC is equal to angle BFC, which is 2 times x plus 2 times y, or 2 times angle BAC. And second of all, we proved this result 2 slides previously, and so angle BFA plus is equal to sine of angle BFA is equal to the sine of angle CFA. We are really suspicious that these two angles are actually equal. All I need to show is that those two angles, they add up to more than 180. Actually, each one is more than 90 would do the trick. So notice that angle, so let's start with that, angle AFB is angle AFB plus angle AFC is simply 360 minus 2 angle BAC, so we can clearly see it here, AFB plus AFC plus 2x plus 2y, or 2 times BAC, is equal to 360, so and there this formula, and this is obviously greater than 180 because our triangle is a scaling triangle, acute scaling triangle, acute, so meaning these angles are less than 90 degrees, so 2 times less than 90 is less than 180, so therefore 360 minus something less than 180 will give you greater than 180. So these two angles add up to more than 180, and as a result, using this fact as well, this second fact, we can say immediately that that angle AFB is actually equal to angle AFC, and they are both equal to 100, so half of this, obviously half of this result, 180 minus angle BAC. So now going back to the points BOFC, we already know BOFC is cyclic, and obviously triangle BOC is an isosceles triangle with O as its vertex angle. Angle BOC, we already know it's equal to 2x plus 2y. So we therefore have so angle, notice that notice that angle OFB is equal to angle OCB. OFB, let me actually draw this final line that I'm missing up here. So there we go. So what I'm claiming is this angle right here, so OFB, so this angle is equal to well, it subtends arc OB. As a result, it must be equal to this angle right here, or let me just actually use some different colors. Let's use black color, I guess. So this angle and this angle are equal because they subtend arc OB of this circle BOFC, and that thing is, I claim, equal to 90 minus angle BAC. And the result is obvious because, as we said, you can just drop a perpendicular from here. We have an isosceles triangle, so therefore this part is x plus y, This part is also so MOC is also x plus y, which means this one is angle OCB is simply 90 minus x plus y, or 90 minus angle BAC. But therefore, therefore we can conclude, notice that angle AFO, angle AFO, so this angle that we're trying to show, that is 90 degrees. So angle AFO is simply equal to angle AFB minus angle OFB. But then, as I said earlier, angle AFB was just 180 minus angle BAC, so this is just 180 degrees minus angle C, as we found earlier, minus an angle OFB. We just found out a few seconds ago that this is just 90 minus angle BAC. So therefore, so that's in parentheses, obviously, the difference is actually equal to, so the BACs will cancel out, and the difference is just 90 degrees as we wanted to show. So therefore, we just proved that angle AFO is 90 degrees. As a result, it is subtending the diameter AO, and it must be on the circle APON. So F is on this circle APON. And that solves our problem. Hope you enjoyed the video. See you in our next lecture.